Hi, welcome to the screencast for both topic D2 and D3 from Chapter 15. D2 looks at antacids, and antacids are aimed at a metabolic process, primarily your digestive process. And your normal pH in your stomach can be as low as 1 to 2 because of the hydrochloric acid, especially when it's digesting food. And it helps to digest, and it also helps kill off any bacteria that you maybe don't want there. But alcohol, smoking, stress, and some drugs can lead to excess gastric juice, and that's when people get indigestion or even heartburn if you get the acid coming back up your esophagus. And you can end up with a condition called an ulcer, where you have damage to the stomach lining. It's like a little blister wearing in there. So antacids are weak bases that help neutralize excess gastric acid. So you've got an acid, and antacid's just going to be a base. Obviously, it's going to be very weak so that you don't have any other damage done. And so most common antacids contain either aluminum or magnesium, and each one has an advantage. Aluminum is slower, but it's longer lasting relief. Magnesium's faster, but it acts as a laxative, which isn't what you usually want with your antacid. They're both metals with some kind of base group attached to them. So I've shown you two different types here. The first one is aluminum hydroxide. Because it's a weak base, it doesn't fully dissociate, but it will take some of the HCl out there and form aluminum chloride, which is just a salt and some water. And the magnesium carbonate's the other one I include, because when you have a carbonate, this would be like Alka-Seltzer, where you see the CO2 being produced as you drop it in there. That is one of the issues with using metal with a carbonate, because you do have gas produced as well, and that may actually make the problem more. So again, big drawback is magnesium tends to act as the laxative, but aluminum tends to cause constipation, and it's even been linked to Alzheimer's. And when you do have it connected to a carbonate, and aluminum could just as easily be connected to the carbonate or hydrogen carbonate, then a lot of times they include a chemical called dimethicone, and you should recognize the name dimethicone and know that it's put in there to eliminate excess gas and to keep the foaming down for it. If reflux is a problem, then a lot of times they contain a chemical, an alginate, to make it float on top of the stomach, because that's where the acid is coming back up. So it'll help protect it. Just puts a coating between the acid and your esophagus. And then if there is any reflux, that coating is the first thing to head up your esophagus. D3 then is about painkillers, which are known as analgesics. It's part of the body's, pain is part of the body's defense. You feel pain to encourage you to stop doing whatever's causing the pain. But if the pain is too great, if it's dominating the senses, you've stopped doing whatever, then pain relief is a logical thing to seek. So painkillers are a group of drugs called analgesics. There's both prescription and over-the-counter. Over-the-counter is commonly known as OTC. And so the over-the-counter ones you've probably heard of are aspirin, acetaminophen or Tylenol, and then ibuprofen or Advil. Sorry about that, I jumped back a page. And then the strong analgesics have to be prescribed, such as morphine and codeine, and then heroin is a non-prescribed substance and illegal. And then local anesthetics that are used are lidocaine and novocaine. Those are also painkillers. And then general anesthetics, nitrous oxide or laughing gas, and then chloroform and diethyl ether are other ones that are used. So the main thing the book looks at is this idea of mild and strong analgesics and how they work. And they really work in two very distinct ways as far as controlling the pain. So the pain pathway, what happens with pain is that the damaged cell releases prostaglandins, and they initiate this inflammatory response, which dilates the blood vessels. Okay, and when the blood vessels dilate, they may cause swelling, and when swelling happens, it usually presses on a nerve, so it stimulates the pain receptors. So then a message is sent to the brain that you're not liking what's ever going on. Another thing that prostaglandins can do is they can affect the body by causing you to have a fever, letting you know something's wrong. But the bottom line is analgesics work by blocking this inflammatory or pain response in some way. So the difference is where they block it. With mild analgesics, this is your aspirin, Advil, Tylenol. And then paracetamol is, if you've ever heard of Aleve, that's the active ingredient in that. So the mild analgesics work by inhibiting the release of the prostaglandins. So at the site of the injury, they don't let the prostaglandins be released. And depending upon how strong a dose you take, how quickly you take it, you may be effective at reducing that release, or there may be quite a bit released and the mild analgesic won't do the job. So again, it includes the aspirin, ibuprofen, which you maybe know as Advil, and then paracetamol, which is like Aleve, and then acetaminophen, which is Tylenol. And they all work in the same way. They don't interfere with brain functioning because they're working right at the site. They also help with the inflammation. Other than the Tylenol, the Advil and aspirin will both help with the inflammation. So these are considered non-narcotics. A couple other things about mild analgesics, and let me just clean up my problem here. So looking at aspirin first, its chemical name is acetylsalicylic acid. It's a derivative of salicylic acid that's been combined with acetic acid. There's an acetyl group on it, the CH3CO group, and there's also a methyl, a carbonyl group on it, and you can find it in the data booklet. Big thing is that using alcohol can increase stomach bleeding because aspirin always will cause some stomach bleeding. Asthmatics are commonly allergic to it, and in children it's been known to produce a syndrome called Ray's syndrome, which can be life-threatening. But the benefits of aspirin is it's a mild analgesic, so it's non-narcotic. It also will reduce fever. It's anti-inflammatory. It's often used for its anticoagulant, so people with heart issues or clotting issues will use it. It keeps your blood from clotting. And then the big disadvantages are that it causes ulceration or the stomach bleeding, as I mentioned earlier, and sometimes slowing the clotting can be a bad thing. Again, a lot of people take it for that reason, but if you have some kind of a bleeding issue, that's not going to be a good thing. Look at the next mild analgesic, acetaminophen or Tylenol. Paracetamol is what it's called in some other areas. It's very safe in the correct dose. It's also a fever reducer. It reduces mild pain. It doesn't cause stomach bleeding. There aren't many allergies to it, and there's no Ray's syndrome. But the big disadvantage is it's not very effective as an anti-inflammatory, okay? And the reason is because it blocks the prostaglandins in the brain instead of actually at the injury site. And so it's not going to have the same benefits at the injury site of preventing that inflammation. I'm not sure why I have it could cause bleeding in the stomach. That is not true of that. But in rare cases, it can cause blood disorders, and it's been linked to both kidney and liver damage, which of course is not a good thing. So again, the disadvantages, it's not an effective anti-inflammatory because it blocks things at the brain instead of the injury, and it can cause blood disorders, kidney damage, and also liver damage. And then the last one, the ibuprofen, also known as Advil or Motrin as its trade names, have the same effects as aspirin, so it does reduce pain, inflammation, and fever. It's effective in low doses. It causes fewer stomach problems than aspirin, but it does cause stomach problems. And in rare cases in large doses, it can cause kidney problems, especially long-term use in a high dosage. So things IB will want you to know is the difference in functional group for all three of these analgesics. If you look at page 19, you will see them there. You'll notice that there's benzene rings in all three of these and in many of the medicines listed there. Another thing I want you to be able to look at these three structures and see if they're symmetrical or not. And you should notice one of them is symmetrical or a mirror image and the others are not. So moving on to strong analgesics then, this is your morphine, codeine, and heroin. They alter the perception of pain, so they don't block the prostaglandin being released. They don't help with the inflammation there. Instead what they do is once the signal gets to the brain, they don't let the pain signal go any further in the brain. They don't let your brain process it. So this is a narcotic because it does affect your brain. It can cause drowsiness and changes in mood. They work by binding to the opioid receptors in the brain. And again, this is something that IB will expect you to know. They're known as the opiates. And it's the most effective painkiller you can use, but they have the potential for dependence and other problems with long-term use, so they're heavily monitored and regulated. So the three main ones that we talk about are codeine, morphine, and heroin. And that's their strength generally, and the way they're prescribed is codeine first, then morphine, and then heroin obviously isn't prescribed. They're all related to opium, and again, they work by bonding to the opiates in your brain. And opium's been around for 5,000 years. It's had great cultural significance, been used for a number of things. It's had a great impact both politically and economically, and it's no surprise all three of these have very similar structures. And my picture here is not so great, but you should be able to see that on this one looks very similar, slight difference right here. And then this one, the heroin's got a slight difference here and here. Otherwise, very, very much the same with just a couple of substitutions. And again, we see the benzene ring along with a couple other cyclic structures on there. So the strong analgesics, there are some reasons for using them. They're often used for acute short-term pain like after surgery. They're very effective for severe pain, and they don't cause bleeding in the stomach or elsewhere. Not usually hard on your organs. The problem is that addiction becomes high. They often cause nausea and drowsiness, so it limits what you can do while you're taking them. And then constipation is another side effect, or disadvantage, I should say. And then the side effects is that they cause constipation, they suppress the cough reflex, which can be a good thing or a bad thing, and they constrict the pupils of the eyes. They also cause what are called narcotic effects, which we'll go over on the next slide. And the first three, these would all be things you might want to suppress. So sometimes these side effects actually are a symptom that a doctor's treating, so they would use the narcotic specifically for that reason, like a codeine cough syrup. Okay, narcotic effects, there's both what are considered short-term and long-term narcotic effects. Short-term are dulled pain. So not only will the pain that you're having at the site of your surgery or whatever, if you hit yourself with a hammer or anything else, you would also have dulled pain, a dulled response to that, because it's going to be affecting the whole body. It also tends to make you drowsy, or is known as sedation, and you have some stupor with that. Can have euphoria, impaired functioning and coordination. Euphoria is just like you're in a really good mood or flying high. Obviously, then that would tend to reduce your tension, your worry, and your fears. And you're going to tend to have dependence and tolerance, meaning, remember, tolerance means you're going to need more and more of it for it to be effective. Long-term effects are the constipation, decreased libido, and then loss of appetite or poor nutrition. So usually not great things to have in your life. Tends to have withdrawal symptoms if it's used for more than short term, which would include cold sweats and anxiety. And then methadone is a name that I expect you to recognize. You probably do from your health classes, that it's an alternative to heroin, commonly used for people trying to break the habit of heroin, or if they've been on morphine or codeine too long. The last two slides here get into the difference structurally. If you look at your data booklet, you should be able to find the opiates, the codeine, morphine, and heroin. And one of the big differences is this amide and the amine group. And up here on this slide, I've got more information about the benzene ring, the things on them. But the amide and the amine group is just a slight difference. An amine group is just nitrogen, okay? And it's nitrogen attached to 1, 2, or 3 carbons, so it's primary, secondary, tertiary. So I remember amine, the amino groups, it's just nitrogen. And the amide with the D in there, I remember that it divides the carboxylic acid or the ester group by replacing the single bonded oxygen there. So dividing up means it has a carbon and the oxygen in there. Amine, it's just the nitrogen, and you have to decide how many groups it's attached to. The other thing to be aware of is this idea that heroin is much more dangerous because the ester makes it nonpolar and allows it to get into the brain, which is going to have a much greater effect.